My name is Joseph Wellner, and we are going to be taking a look at Mathcad Prime today. So let me go ahead and share my screen and collapse this for a second, and we can begin presenting. All right, so my name is Joseph Wellner, and we are going to be taking a look at Mathcad Prime 5.0. This presentation is brought to you by TriStar Incorporated. TriStar Incorporated is a value-added reseller for PTC. We deal primarily with the providing of the software and implementation of the software, whether that is Mathcad, Creo, Windchill, or other PTC products. Today we're going to be taking a look specifically at Mathcad, and in this presentation we will first go through Mathcad and orient ourselves with it. Then we will take a quick look at a Mathcad demonstration and then explore further resources within Mathcad that can be used to help you get up to speed and apply it for your specific processes or needs. First, let's go ahead and address a few questions to help us understand Mathcad. First, what is Mathcad? Well, Mathcad, or PTC Mathcad Prime 5.0, is an engineering notebook. This engineering notebook is designed as an application for engineers to document their design process, document their engineering process, and use this notebook to help them format and collect all of this information in one central place. Now, the next question is, what problem does Mathcad solve? Often in industry, we lack standardization. So when we are working with a specific customer, that customer might document information one way, another might document it another. Often a good way to make sure a business succeeds is to standardize its processes or standardize those processes, observe those processes, and then improve on them. Mathcad helps us do that by allowing us to store all of our information in one way and not have multiple documents that we need to interrogate to understand an engineer's design process. Think of a Word document having the documentation that is necessary for the formatting of the text, and then think of maybe an Excel document containing data that is then used within another file type to analyze that data. Instead of having all of these different programs that are used to organize that information, we can use Mathcad to store it all in one place, take care of all of those operations that are necessary for engineering, and allow us to standardize that process. Then we also have the problem of organization. Very much similar to standardization, all data is often not stored in one place under one format. Mathcad allows us to use this single program to store all of our data, create a single format type file, and then even use already created design studies as templates for new design studies. This speeds up our design process, speeds up our documentation process, and helps create a standard operating procedure that can be improved upon over time. And finally, the problem of transparency. On top of organization and standardization, often companies have a problem going back through and seeing clearly what is happening in our engineering process. Sure, we can have many documents, different checkpoints, and deliverables that are necessary for that process, but having all of that information stored within one file, stored with a similar template, stored with a company standard process, will allow us to interrogate that quickly, understand what is going on, and help maybe troubleshoot other problems within our company by using that. And another advantage with this transparency, Mathcad is meant for engineers, but is not only usable by engineers. It does not need to be a specialist that is accessing the Mathcad documents. It can be a non-specialist, and they will be able to get information from those documents clearly. Now, why is Mathcad a good solution? Well, it is an application designed for engineers. and as an engineering tool, allows us to perform different operations to justify our design logic, create our mathematical logic, and document our problem-solving process. It also allows us to perform and execute different mathematical simulations or models so that we can quickly derive solutions to problems from already created information. We also have the user-friendly interface, and Mathcad is a very user-friendly tool. It does not require training, so specific training. It allows us to very intuitively go into the program, start using it, and start applying it to our specific needs. It's also very useful for non-specialists. This goes back to that transparency issue. Someone can go into Mathcad, view an already created Mathcad file, and understand what is going on within that file without either one, having created it, or two, being a specialist that deals specifically with Mathcad. And finally, Mathcad is a good solution because it is a PTC product. This goes with the PTC Creo and PTC Windchill suites of products. This allows us to integrate those two, derive specific values within our Mathcad workbooks that can be used to drive our Creo models, can be used with Windchill to organize that data and really tie it all together intelligently so that any information or changes propagate efficiently from one file to the next. Now let's go ahead and move into Mathcad, and we can take a look at the specific operations that we can perform there. This demonstration is primarily going to focus on interrogating an already created workbook and then looking at how we can use a template to create a similar workbook very quickly. We will also go through the interface so we can understand what we have in Mathcad and what we can use in Mathcad, and then we can move on to the next section. So here I'm just going to open up Mathcad. We can see it on my screen. Hopefully, let me go ahead and make sure you guys are seeing it. Yep. All right, great. All right. All right, so here we are in Mathcad. And the first thing you will notice is that we have a blank page right here. And this page has a grid on it. This grid is primarily used in Mathcad to document specific locations for either our math or our text, as well as our images and graphs. Mathcad is a whiteboard interface, meaning that we can very quickly move items around, add new items, and format efficiently. This is huge when it comes to mathematical documentation. Often, if we are trying to document formulas in Microsoft Word or other word processors, we cannot quickly do that. Those programs aren't built for that kind of documentation, and we have a huge disconnect from the mathematical side and the text side. Often, if we try to use something like Word to document, the documentation is painful, and we don't want to do it, so we don't. The best way to document is to do it, and this tool allows you a good interface so that you can painlessly do it and maybe even enjoy documenting our information here. Now this grid allows us to change it as well, so we can go to document. There we have show grid. We can toggle that on or off. We also have grid size. We can change that from standard to fine, and you can see that now we have even more selectability and maneuverability within that page. Also, if we want to add a new page, we can always just go and click at the bottom of one and quickly add another. This allows us to move freely from one page to the next. Once more, a very useful formatting thing. Now, as far as our operations go, all of that will be contained in this ribbon interface. And this ribbon interface has different tabs, as you can see at the top. And each tab includes different groups, and each group has its specific operations that can be performed or added to our workbook. Here in the math, we have our regions. Regions can be chosen as math regions, where we define mathematical operations. we have solve blocks, we have component charts, we also have text blocks and text boxes and images. So all of these can be included very quickly in our Mathcad workbooks. Often with the ribbon, we don't even need to access it to create some of these. We can just start working in the interface. So if I start typing, that would immediately be a math box. This means I can define math within this box, define a formula, two times y. And notice that y isn't currently defined, so it even checks that math, lets us know what's going on. We can also right-click and choose to insert text blocks. You can see right there, it will just give us a box that we can quickly put information in. We can do text box, which would give us a small box that we can put information in. So we can quickly create these, move them around. Notice that even if I don't use them, they automatically go away, which is very useful for the creation of content here and formatting. Now let's go ahead and move past regions. We'll take a look at that more when we open up a completed workbook, but I want to look at these operations group as well. So notice that here in the drop-down, we have different algebra operations, equation break, calculus operations, derivatives and differentials, as well as limits and comparison, definition and evaluation, and engineering, as well as vector and matrix operators. All of these can be used within Mathcad. We also have different symbols that are quickly available. All these Greek symbols that can be used to define variables or have predefined values based on their common usage. We also have different math symbols, monetary, Hebrew, tags, so on and so forth. And we have programming. So Mathcad, along with allowing us to document our math and our text, allows us to even insert programming language and evaluate that within the same interface. Constants, symbolics, and so forth. Then we have the style, which is used primarily to manage the view, and units. Mathcad really allows us to manage our units more than any other program. The unit manager does have its default unit system, which is right now set to SI. But for any measure that we have or any variable with a defined value, we can choose what units are applied to that value within that value's definition. This means that the units are intrinsically tied to that variable's value. So if we change the units in a downstream value that might be calculated using that original variable, and then change those units of that value, the program will handle the translation from one unit system to another, or from one larger unit to a smaller one, so on and so forth. This goes for any unit type. Mathcad will also check our unit. So let's say we try to add a variable that, or a variable that has meters with a variable that's driven by seconds. In that case, Mathcad would let us know, hey, these units aren't compatible, and we'll double check our work in that way. Then we have the input and output tab. Here we have the ability to create and cache worksheets. This means that we would store all the referenced worksheets with the file that references them. We also have our data import and export. So although we can perform the majority of our functions within Mathcad, often we might have tables defined, let's say within Excel, that we would like to reference specific data there that we would like to pull in and analyze in Mathcad. We can always import or export data from Excel or to Excel using these operators here. It's very quick. We can imprint that or embed that within the Mathcad item so that if we store that workbook once more, those worksheets will be cached with it. And then we have functions. Notice that here we have a library of all kinds of functions for all kinds of situations. This goes from statistics to signal processing to differential to design of experiments. All of these have their own drop-down menu with their own functionality. Notice that if I hover over them, we do have those tooltips. Mathcad has done a really good job with defining tooltips, making sure that we can use them to choose the right function for our desired effect. Then we even have matrices. We can define matrices here. So you can see this insert matrix box, very similar to insert table. We have different matrix operators, functions, plots. We can create plots within Mathcad, whether that's 2D or 3D. And unlike other situations or other documenting devices, Mathcad will allow us to tie those plots to math included in that document, meaning that if we update any variables that are used to determine that plot, then the plot itself will update automatically. Then we have math formatting, text formatting. So we have these formatting options. We have calculation. Right now it's set to auto calculation, which is the default, meaning that it will automatically push through any changes. Stock calculations. We have document options, and then resources. And we'll go over this resources tab in a minute. But now let's go ahead and open up an existing workbook. And to do this, I can very quickly just go up here, say open, and open. And then we have here a finish beam deflection notebook. So as soon as I open it, notice that we have one of 3 pages down here. We have the ability to do find and replace. And we have the pages themselves. And right now we just have a title here, deflection of beam. Maybe I would like to add a description. I can go ahead and just right click and say insert text block and start typing out my description. Simple, or let's say analysis of simple beam deflection. And then we can always go up here, text formatting, format this as needed. And this text block, we can just quickly move around this interface. Notice that we don't have to tab or press enter a bunch of times. We can just move it around in that whiteboard interface to achieve the functionality. And now here we have definition, or part 1, definition of beam properties. We can always select this. Maybe we want to emphasize these different sections. Definition of beam properties. Here we have that cross section, and we can define the cross section values. So looking at this beam straight on, we can see that it has a width and a height. And here over on the right hand side, next to this picture, which we can freely move around, we have that W with its defined value and the H with its defined value. And then underneath that, we have the formula that is used to calculate that moment of inertia value. And here we can see it evaluated with centimeters cubed. Let's say we go back here and change one of these values, maybe from 10 to 11. You can see automatically that updates and takes that new value into account. Maybe with this moment of inertia, we would like the units in meters. We can always select that and just type over, say meters, evaluate that in meters. We can also go millimeters, or even quickly change from one unit system to another. Go feet. Notice that automatically it handles all of that calculation and translation from one unit to the next and prevents errors of that type. Let's say we have another variable. Let's call this one U, and U is equal to 1 second. Let's go ahead and redefine this. And then we tried to create a value, let's call it O, and O is equal to U plus H. Notice that H, these units are not compatible, so it double checks us there. And so in that way, Mathcad provides a lot of utility, making sure that we have all of those simple errors handled and offloaded to a system that will not make errors that humans would. Now let's go ahead and continue. We can see here next that we have a material. This material has been defined with a name as well as a Young's modulus. So here we just have that aluminum name and we have Young's modulus. Material name is defined within a text box and Young's modulus is defined within its own text box. This means we can quickly move it around, format it, and here we just have that math box. Let's say we wanted to move all of these over for formatting's sake. We could select them all, move them together, and have that clearly displayed for anyone else interrogating this document. And then here we just have beam dimensions. And these dimensions are defined according to this picture. And this picture has been brought in from an external source and embedded within the document. Notice that we can move it around with that whiteboard interface. We can format it as needed. And then we have beam length, its value, its load with a value. All of these are clearly depicted in the picture, load position, and from there we can perform our calculations. With these calculations, we do want to understand the deflection. So here we can say deflection will be defined as a function y with an input of x. So this is deflection at the location of x. Let's say we wanted to explain that a little bit more clearly. We could always right-click here and insert a block or a box and say y of x is deflection at location x on beam. And so just like that, we can quickly put this in, have it formatted for us. We don't mess up that display of the formula. And this formula is intelligent symbolic math. So we do have all of this information stored here. All of these variables are tied to variables created or defined further up in the workbook. And that means if these variables change, then its evaluation will change. So here we have deflection at midpoint. We have y at L/2. Maybe we want to add some description here, insert, instead of a block, just a box. And we can say y of L/2 is the deflection at midpoint of bar length L, midpoint being at L divided by 2. We can just have that right there. If we need to, we can expand it, change the formatting, but we can just add it very quickly and not have to mess around with that formatting too much. And then finally, we have deflection along beam. Maybe we want to be able to see a graph of that deflection taking place. We can see that here with a defined range of x. So we have x starting at 0, incremented by 0.1, all the way out to L. And L once more is being pulled from the definition of L up here in beam length. And we have this intelligent graph. We can always double click this graph, change its variables, change the locations of these x and y axes, and access more intense formatting options using other operations. But let's say that is where this workbook ended, and this company deals a lot with beam deflection problems and would like to have a documentation of this beam deflection based on this operation, where first we have a cross section with its attributes defined, its moment of inertia defined. Then we have the material chosen with the Young's modulus, beam dimensions. All of these can change, but the general process is going to be the same with that deflection value or operation function, I should say, deflection at midpoint information and deflection along beam. Well, we can go ahead then and create a template. And then when we create that template, or rather create a new document using beam deflection, we can reference that template quickly and save ourselves the process of reformatting this document, recreating all those variables, and redefining our information. Also, yep, so let's go ahead and do that. So now I can just say new. Oh, try that one more time. Hover over new. New from my templates. I can browse to a location where this template is stored, open it up, and there we have once more deflection of beam. Maybe I would like to bring some of this information over. I can just select it, right click, copy, go from one file to another, paste. Then we would just have the definition of the beam properties. We can double click in here. You can see missing term or expression. So right now it's going to show us what variables are undefined in this template and where we need to enter values so that we can create our final beam deflection document. Even notice that the graph has been defined without any values. It's referencing once more the deflection created, deflection at midpoint, and these x values. So I can go back up and just start working on this. I can click in here and say my width is 15, my height 20. Notice that right now, with that width defined and my height undefined, we do have a moment of inertia, this h value, which is a constant, being pulled in and used for our value here. So Mathcad is not foolproof, but it is a lot less, let's say, a lot less error prone than if we were just doing this by hand. So we can see here our units. These units are obviously not right. This h is this green color, which means that it's an internal variable or internal constant, excuse me. But once I go ahead and define a value for h here, notice that this h value is now being tied to the one within my moment of inertia calculation. We have that value. And then here once more, I could just say, let's say steel for the type, Young's modulus 200, beam, and then move on to the next section, dimension of beam. So here we can just look at this picture, which is standard. Then we could say the length of the total beam, okay, that makes sense, would be, let's say 200 meters. The load would be 1,000 newtons, and the load position is at 120 meters. Now that we've defined all of this, notice that here in the calculation section, immediately we have the deflection defined, which has been given for us. Then we have deflection at midpoint, and we have that total value of the deflection at the midpoint. Maybe we want to see it in meters instead of millimeters. We can just type there and say meters. We can see it's deflecting by negative 7.867 meters. And then even at this bottom part, we have the deflection along beam. Notice that we have this graph. We can see a little bit of asymmetry since the load is applied off of that midpoint. Let's even skew it a little bit further. And we can see that here that graph is updating maybe even a little further. Yep, so you can see that deflection is moving over. Max deflection would be here, and we could compute that as necessary. But you can see how this document has been structured and uses that template to quickly have the defined sections, the defined information that, or rather the information that we need to define. And then once we define those variables, quickly gives us an output based on already predefined math. Also, if we need to reuse any of this data, we can move it quickly from one document to another. So maybe we want to add this to the document over here, or even go in and edit the template. We could choose to do that, just select it, paste it, move it around, and format it as necessary. So Mathcad is a very useful tool, especially for speeding up that creation of the documentation by using templates. It also allows us to perform mathematical functions or mathematical evaluation within the interface, perform different functions that are more complex than just regular computational mathematics, and do all of that within one format, within one file type, and really just streamline that process and make it clear what is going on. And now finally, I would just like to take a look at a couple of resources. So if you choose to go in and take a look at Mathcad yourself, see how you can apply it, PTC does offer a lot of resources for you. You can choose to go to the references. This is primarily for installation. Then we have tutorials. Tutorials will take us to PTC's website for tutorials. Keyboard shortcuts. This gives us a PDF that includes all of the shortcuts for Mathcad. So here you can see regions, math constraints. All of this is covered in this PDF, so you can maybe print this out, put it on your wall, and get very proficient in this so you can create these documents even faster. And then we have here the PTC Mathcad community. And this is super useful for new users. I especially like the engineering resources. This provides a lot of examples of different formats, different worksheets that can be created based on the operations or applications you're using it for. So we have algebra and geometry, calculus, statistics and data analysis, different types of engineering, oil and gas. You can see each one of these will have its own specific worksheet type. We also have the worksheet names, categories. All of this can be referenced for you to understand how to use Mathcad and apply your specific workflows to the tool. And then we have Learning Connector new users. Most of this is primarily for just understanding what is going on within Mathcad. If you choose to get Mathcad Express, I really highly encourage this engineering resources. Download a couple of those workbooks, take a look at them, and understand how those processes are implemented, and you will be very far in understanding how to use Mathcad for yourself. And with that, I am going to end my demonstration. Let's go ahead and go back to the slides. This is the end of the presentation, so it is quite quick. I just wanted to go over those resources with you, make sure that you understood what Mathcad is and how it can be used, and also that user interface, how it is used on a micro level. If you have any questions, please feel free to reach out to me. I am not seeing any questions in the chat, but if you have some in the future, please reach out to a sales rep. You can also reach out to them and ask for me specifically. We can go through this, take a look at what you were trying to do, and implement a solution with Mathcad. Otherwise, thank you very much for attending my presentation. I am very glad that you were able to be a part of this. If you have any questions in the future, please let me know. Otherwise, let's see. Not seeing any questions. Let me expand this. How to integrate Mathcad in Creo? That is a good question. I do not have an example for you right now, but I can talk you through the process. It is very interesting. So you would have a Mathcad workbook. Within that Mathcad workbook, you would designate the variables that you would like to then transition or tie to your Creo model. And then within the Creo model, you would reference that Mathcad workbook and be able to define those variables. If that's a topic that interests you, I would love to demonstrate that for you, maybe a later date. So let me see here. Let me direct you to the website. All right, so our website is here. This is TriStar Inc. And you can contact us by just going to contact, of course. And then you can always email sales@tristar.com and just say, hey, I watched the Mathcad demo and I had this question. I would like to go over it with an application engineer. And then I would be glad to go over it with you. We can set up a go-to meeting for that. Also, here, let me go ahead and put my email. I'll just use Mathcad to do it. Put my email up here. You can take it down. I'll also put it in the chat. So my email is joseph.wellner@tristar.com. And you feel free to send me an email at this email, and I will get back to you. So good question, Alexi. Any other questions? All right, well, thank you very much for attending. I look forward to talking to you soon, Alexi. Otherwise, please feel free to reach out to anyone else. If you have questions about Mathcad in the future, reach out to me specifically. Otherwise, thank you for attending, and I will talk to you all later.